demonstrates the effects of the impact and shows the marks where the cockpit was torn from the rest of the fuselage. The high-energy objects that perforated the aeroplane were also found in the bodies of 3 crew members seated in the cockpit. The preformed fragments have distinctive shapes, cubic and bow tie shaped, and were made of a ferrous metal. Some fragments had traces of aluminium and glass on them, proving that they had perforated the aeroplane from the outside. The 2 left windows of the cockpit particularly show perforation by preformed fragments. Many traces of explosives were found on pieces of wreckage. Also, certain traces of paint were found that match paint on parts of a missile that were recovered from the crash site, and missile fragments found in the cockpit and the left wing. The retrieved fragments and traces of paint point to a missile carrying a specific type of warhead and launched by a Buck surface-to-air missile system. During the investigation, a number of computer simulations were conducted. These support the surface-to-air missile scenario. The detonation of a 9N314M model warhead was simulated to calculate the point of detonation as well as the damage that could be expected. The warhead exploded on a location in space less than 1 cubic meter to the left of and above the cockpit, spraying its fragments in a characteristic radial circular pattern originating from the missile. These patterns match the damage found on the reconstructed forward section of the fuselage. Further proof of the detonation position was found in the last milliseconds of the cockpit voice recorder. This contained recordings of 3 crew microphones and an overhead microphone in the cockpit on separate channels. During the final milliseconds, these microphones recorded a sound peak. Based on the difference in timing of the recordings of the sound peak on these 4 microphones, a direction could be calculated.